Welcome, guys. Good evening, all of you. And today I'm going to discuss a really interesting idea. Uh, Hello, guys. Hello, guys. Hi, hi. Good evening, all of you. So today I have a really interesting idea on my mind. Okay, so I was just going through something interesting called Saint Petersburg paradox. So what is Saint Petersburg paradox? It's something to do with what we are learning. Okay, what we are learning the mainly for this 2022 batch we are learning the discrete distributions, right? Now let's forget about the paradox. I will give you a condition. Okay, I will give you play a game with you and you have to tell me, each one of you, that what you have to do. Okay, that's my condition with you. This is the game we are going to play. Okay, so stay tuned on this. Okay, so perfect. So we have some new students over here. Welcome Swapnil, Nasir, and Madhav. Hi. So three new people over here. Welcome to Cheenta Statistics Analytics Department, and I hope you will have an enjoyable journey with us learning statistics. Okay, perfect. So going straight away, let me discuss a bit about the discrete distributions that we have to give you a brief overview of what we have done. So what we have done, uh, we know that. Just give me a minute. Yes, just to give a more better view of world and green board. Okay, so let's devise discrete distributions. So what is there in discrete distributions? We have a random variable x, which takes values in x1, x2, dot dot dot, infinity, countable set. Okay, x1, x2, dot dot, infinity. These are real numbers. Okay. Now, tell me that each probability of x is equal to xi is equal to pi. Okay. Probability x is equal to xi is equal to pi. That's the basic idea. Such that summation of pi is equal to 1. This is a basic idea. So now this is a basic idea of discrete distributions. Okay. This is a basic simple idea of discrete distributions. Now what is the game I'm going to play with you? Game is the following. Is that, let's say I'm asking you giving it a game. Okay, what is the game? The game is the following. That you're tossing Bernoulli. Last day we also done geometric distribution, so you will be understanding this much more better. You're tossing a coin, random fair coin. The idea is that you call success as heads. That's a success. Now, I will ask you this question simply. Let me explain the game first. That if you get, if success occurs, the first success occurs on the kth toss, I, the Cheenta, will give you 2 to the power k rupees. Okay, if you're from outside seeing it online, then 2 to the power k, whatever your currency is. Okay, if you get first success on the kth toss, then you get 2 to the power k rupees or your currency, right? So my question is to you that will you play the game or you will take rupees, or you will take one platinum course for free? That is 7899 for 3 months for free. This is a question to you. Okay? This is a simple question to you. Okay, what is the question? That will you play this game or will you take one the platinum 3 months के लिए platinum course free? Which one will you take? ठीक है? So I will start with each one of you. ठीक है? I will start with each one of you. Can you hear me, guys? Yeah, I hope all of you can hear me, right? So did you understand the question, guys? Did you understand the question? All of you understand the question? Now I will go one by one and ask you. Okay, Bhushan, what will you do? Tell me. And all the people on the live, tell me what will you do if I play this game with you. The game is that I will give you to the power k rupees or your currency if you get the kth toss. Okay, if you get the first head on the kth toss. Okay, or will you take one platinum course for free? There is 7899 for free. Just tell me this.
So what is the probability of success here?
It's a fair coin.
Okay.
So,
I guess I will take one platinum course free.
okay, why is that true?
Maybe
Tell me logic, okay? Don't tell it you're a statistician in the making. Give me numbers. If you ask me, I answer me something. I will ask you why, and you have to answer me. Be prepared for that. Okay, can I move on to the next one? Bhushan, you think about it. Hemant, what will you do?
We will first calculate probably the expectation of the game.
Okay.
And then if it's greater than
okay.
7, 8, 9.
Let's check it. Okay. All of you think the same? Polomi, Sneha, Tanvi, Nasir, Mayur, Madhav, Kushal, Swapnil. All of you think the same? Arisha? Swapnil, you think the same about it? Kushal, you're an economics students. What do you think? So this guy is telling that they will calculate the expectation of this game, okay, and then they will take the decision. Okay, calculate the expectation. Please go ahead and calculate the expectation. Someone, can you calculate expectation? Can someone help me in calculating the expectation? What do you think? So I will give you 1 minute to calculate expectation, guys. Mostly the 2022 people. What is the random variable? Can you define me the random variable? Anyone from 2022 batch want to define the random variable? Follow me, Tanvi. Define the random variable. Anyone? Nasir? Yeah, Madhav, you want to share? Sure, go ahead.
Yes, sir. So actually, a random variable is nothing but it's a function which maps from a set of possible values, set of sample values to a range of to real numbers. Sir.
Sure. So what will be the result over here? What is the sample space over here? What is the random variable over here?
So here the sample space is the number of tosses, sir. N equal to 1, 2, 3 up to k, and
no.
real values will be.
अच्छे से सोचो. What is the sample space over here? What are the possible outcomes? It can be heads. It can be tails heads. It can be tails heads, right? It can be tails heads, right?
Oh, yes, sir. This
is the sample space.
Yes, sir. Yes, sir.
All of you understood this?
Yes, sir.
The 202 people. Swapnil, did you understand? No. Okay, so do you know what the sample space is, Swapnil? Okay, so what is the experiment over here, Swapnil? We are tossing the coin until we get the first heads. I hope you're understanding my language, Swapnil. Is everything? Yeah. So we are tossing the coin till we get the first heads, right? That's the experiment. You will play the game till you get the first heads. If success first occurs on the kth toss, then you get 2 to the power k. So therefore, the game is what? The game is that you're playing the game such that you get the success. Like you stop playing the game when you get the first success. That's first heads, right? Do you understand, Swapnil? So does this make sense? Does the experiment make sense? That heads and then first failure and then first heads, failure, heads, success, failure, success. These are the only opportunity, only experimental outcomes, right? Then you will stop playing the game. This is the sample space, right? This is the sample space. Now, out of the sample space, what you're doing is that we are assigning values. What is a random variable over here? Random variable is interested in how much you will earn. There is 2 to the power k rupees. That for this one, for heads, you get one success in first toss, you get 2 rupees. For you need 2 tosses, that means you get 2 to the power 2 rupees. For this, you get 2 to the power 3 rupees. For this, you get 2 to the power 4 rupees, and it continues. So this is a random variable. This is how it's defined. X is a function from the sample space to 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power dot. What is the probability of each one of them? Probability of x is equal to 2 to the power I. It's same as getting probability of ith trial में first success. Did you understand this part, guys?
Yes, sir.
Madhav, Mayur.
So actually, we are considering here a geometric distribution.
Yeah, we are considering geometric distribution. You're right. Kushal, Swapnil, Nasir, did you understand?
Yes, sir.
Are you sure?
Yes, sir. Yes, sir. Yes.
Perfect. Now, understand. So, when will you play the game? As your seniors have told, that you will play the game when the expected value of x is more than 7899. Right? That's the course of one course ka fee. So now tell me that now let's calculate the expectation of x. All the 2022 people, can you calculate the expectation of x, guys? Can you calculate it? Yeah, Pawan, you're right. It's geometric series. Can you calculate the expectation of x now? Bolo. Anyone from the 2022 batch? Pawan, it's not a geometric series in the making. It's like a transformation of the geometric series, okay? If it's get k, then we transform it to 2 to the power k. It's a function of the geometric series, geometric random variable. So yeah, someone tell me the expectation of this. Anyone, guys? I mean, in the 2022 batch.
Expectation of geometric distribution is 1 by 2.
यहाँ तो geometric distribution नहीं है. यहाँ पर we defined it. These are the xi, these are the pi. So probability of ith trial में first success means what? The first I minus 1 में failure, that is half to the power I minus 1 into half the success. That is equal to 1 by 2 to the power I. Okay. So, no, Sneha and the senior people don't answer. Others, what will you answer? The juniors, please answer, guys. The seniors, please don't answer this simple stuff. Did you understand the random variable? These are the xi's, x1, x2, x3, and it goes on. This is a pi. Pi is equal to 1 by 2 to the power I. Did you understand this, guys? Two people? Tanvi, Sneha, Madhav, Mayur, Nasir, Palash, Polomi, Priyank, Swapnil. Okay, what about Swapnil? No, don't you know how to calculate the expectation, Swapnil? Expectation of x is calculated by summation of xi pi. So it's very natural. We are putting probability the weight pi to the xi. This is very natural. You should see the videos, recording, Swapnil, to understand the logic behind it. So xi is here 2 to the power I, right? That for the ith, you will get 2 to the power I. And if x is equal to 2 to the power I, uska probability kya hai? 1 by 2 to the power I. We have calculated here. So it's summation of 1, right? So it's actually equal to infinity. The expectation is therefore coming out to be infinity. So my question is to you, then, is that will you play this game or not? No, we stop the game is this. You play the game, okay, till you get the first success. Now my condition is that if you get the success of the kth toss, I will give you 2 to the power k rupees. ठीक है? Or you cannot play this game and take away 7899. Which one will you do? Right? So which one will you do? This is the game. Did you understand, guys? So did you get the expectation? Yeah, the expectation is totally correct. We can analyze expectation. It's finite. It's finite. It's infinite. It's okay. Expectation is infinite. Now, will you play this game or not? Now the game is for you. Will you play this game or not? Tell me. I hope all of you understood the problem. It's a very easy problem. The other one is dependent on chance, but you're getting an expected value of like infinite, right? Okay.
One should play the game.
One should play the game. One should play the game. Okay. So I will do a poll now that I will ask you now. Okay, can't I do a poll? No. Oh, they have cancelled the poll wala option for a teacher. The probability of getting more than 799. Okay. But let's say in general, like, how do you select? Like, you're thinking that you will not get the whole course, or maybe what if I tell you 100 rupees? What will you do?
Sir, I have a question.
Yeah, bolo.
सर जो गेम खेल रहा है,
हाँ,
वो जो गेम खेल रहा है, वो जो अगर ये गेम भी खेलता है, तो वो रुपया का इस्तेमाल क्या वो कोर्स ज्वाइन करने के लिए ही करेगा?
No, like it depends upon the person. I mean, let's not take the rupaya wala course joining. Okay, let's say I will give you 7899. I will give you 7899. Let's say.
Sir,
Yeah.
so but there is high chance we will get head on the very first spot. No? Like its probability is half.
Okay.
So I think one should not play the game and take 7, 8, 9, 9.
Okay, what if I tell you that I will start from 2 to the power 100? Like this. Then?
Okay, then one should go for the game.
How much
Like-
money will you spend? That's the question. Thing is that you have to give a minimum fee. How much fee will you give? You will tell that I will give the minimum fee of this 2021 2 to the power 100. So the thing is that you're thinking in terms of game, in terms of the like if I ask you whether you will play this game or not, that's the thing. Whether you will play this game or not, that's the thing. So then what will you do? Here actually everything is in profit. Let's do it. Let's you can change this game into a non like a losing scenario also. Let's say. So you guys are telling me that you will play this game, you will not play this game, you will just directly take away rupees 7899 just because there's a chance over here of not giving something, but you will gain something with surety over here. But understand this, as you're telling someone told me something, right? Someone told me that the probability of getting 2 to the power 1 in the first toss is half. Understand, therefore the probability of getting the rest is also half, right? You understand this? The probability of getting rest is also half, right?
Yes, sir.
The probability of getting rest is also half. So what amount of fees you will give to get this game? That's the idea. So how do you decide? The decision factor is what? The decision factor is you calculate the expected value, and then you decide whether the expected value is greater than that or not. And since the expected value is infinite, it's the expected value you get, the average, because you don't know what can happen, right? You don't know what can happen, right? Suppose I ask you to play for 100 times. Then you know that 100 times on average, then you will get this. So on average, you will take only. See, if I ask you to play 100 times this game, will you do the same thing? You will take the money 7899 every single time, guys? That's my question to you. Not say once, but I will say let's play the game 100 times. What will you do, Polomi and others? If I ask you to play the game 100 times, what will you do then? You will just take the money right away? Like, that's my question to you. This is my question to everyone. So you guys are telling that you will not take the course, you will just take the course or maybe the money I will give you with certainty. Okay. And you will go away. So you will get 70,000, 78,000, 79,000, let's say, in 10. So what if I give you the chance to play it 100 times? What will you do? That's my question to you. Tell me, guys, what do you think? How to decide the whole thing? Follow me. Others, Swapnil, Tanvi, Priyansh, Kushal, Nasir, Madhav.
सर इसमें क्या सिनेरियो है ऐसा कि अगर हारते हैं तो कुछ देना नहीं पड़ेगा?
नहीं, कुछ देना नहीं पड़ेगा, सिर्फ लेना है. You will only get and get.
अगर पहला चांस में जीत जाते तो 2 to the power 100 रुपीस मिल जाएगा.
नहीं, ये वाला गेम छोड़ दो. Let's go to the initial game. 2 to the power 1, 2 to the power 2, वैसा वाला. See, I'm sure that if you play this 100 times, on average, you will get more infinity rupees. I can show you by simulation. You want to see it by simulation, guys? That you will get 2 to the power k rupees. So, what is the average value you will get? If you do play it 100 times, x1, x2, xn, 100 times, the average value you will get what? X bar. The expectation of x bar will be same as expectation. X bar is what? Expectation of x bar is what? X bar is what? You will take the mean of all this. Let's say you take the sum. That is the earning, right? Of yours. X summation of xi. These are the individual meanings of each of the game. It's some. If you take the expected value of it, you will get, by the addition of summation of the expectation, you will get expectation of xi, which is ISI infinity. So my question is that what will you do? It's an x1 times, okay? On average, you will get, like, the average value you will get, okay, is like the average value, okay? If you just take the geometric, it's the geometric, okay? The average value you will get is around, if you take geometric only, then on average, let's say, these are geometric, okay? Geometric P. So the expectation of xi is what? 1 by half, that is 2. You will get rupees, like in 2 steps you will get the whole thing. So summation of this will be around 200. Okay, not 200 maybe. Yeah, unexpected value is 2. Okay. Like the expected number of tosses you will get the first head, it's 2. So let's say I make it 100 to the power this, or maybe something. So my question is that, the simple question is that, will you play the game or not? That's a simple question. Will you play the game or not? There is no risk over here. The idea is that will you play the game or not based upon the expectation value or what? That is the idea. Here, I will play based on the expectation value, of course. I mean, that's how we should play. Now tell me your suggestion. Like, you want to play really safe, you want to get that money, so you don't want to play that game. That is one way of approaching. Hemant is asking, want to ask the probability of getting more than 789, and that's also done. Okay. What others way?
इसमें क्या पहला सक्सेस के बाद और खेल सकते हैं?
Yeah, no. You cannot play after the pehla success. One way of asking the question is that you think that these are the very, very few metrics you think that you want to find a probability the x is greater than 7899. Another is that this is a very good way.
सर अगर और नहीं खेल सकते हैं तो एक सक्सेस की बात करते हैं, फिर अगर हारने का प्रोबेबिलिटी बेसी है तो खेलना चाहिए, नहीं तो नहीं खेलना चाहिए.
Okay, you don't want to play it. Fine, perfect. So now suppose I tell you this one. I tell you I'll change the game a bit so that it fits your mind. Let's say initial. Let's take boil down to 7899 to this game. Let's take ₹3. So first toss me will get to the power 1, second toss me will get to the power 2, third toss me will get to the power 3, and it will continue. And or you will have played ₹3. Which one will you take? So you guys are thinking in terms of probability x is greater than 3. What is the probability x is greater than 3, right? You're telling in thinking in this term. What is the probability that x is greater than 3? You're thinking in this term. Okay, that's nice. What will you do in this game? Tell me.
So in this case, since if we get heads on the first toss, then we will be at loss because we could have gotten ₹3, but we're getting 2 only.
Yeah.
So, but in any other case, if we get the heads at the second or third or any other toss, we will always be at the profit.
Okay, perfect.
So in that case, I feel like I should go ahead with the toss.
Okay. You will get with the toss. Perfect. So my question is that for which ₹x you will play the game or not. So they are thinking in this way that I'm getting ₹x. So understand that Instead of doing that, what they are doing is that they are seeing this 2 to the power I minus x into 1 by 2 to the power I. Right, guys? So they're seeing the loss that it's 2 to the power I minus x or this. Excuse me. Sorry. Yeah. So whether you will get 2 to the power I, are you seeing the 2 to the power I minus x for the profit? Guys, that's my question is. So we can blow it by into 10,000, okay? Then it will make much more sense to you. 1 rupee may not sound good to you, but I can blow it by 10,000 into 10,000 to each. Then it will make some difference. So when will you play or not? How are you deciding? That's my question to you as a statistician in the future. Tell me how you decide. This is a very good question I'm asking. Tell me how will you decide? Tell me the general case, how will you decide? How do you decide whether you will play a game or not? That's the thing. Here your random variable is not 2 to the power I but 2 to the power I minus x. Is it that true? What do you think? Just tell me, guys. Anyone? Swapnil, what is your idea? Tell me. Mayur, Nasir, Madhav. What is your idea? Tell me. When will you play the game or not? Time is passing away. Please answer. Sneha, the 2021 people, how will you decide? Kartikya, how will you decide the game? Bolo, bolo. If the expectation is defined, then expectation. But expectation can be infinity also. The expectation can be infinity also. So one thing you can do is like this, that in that previous game, you get 2 to the power 1. Okay, and you lose minus 7899, right? This is the idea. This is the final outcome of yours, right? In the second toss, if you get it, that means you get 2 to the square minus 7899. The third toss, you get, this is the idea, right? And it goes on. Iska probability is half, iska probability is 1 by 2, okay? Iska probability is 1 by 3 and it goes on. So the expected value is coming out to be what? Summation of 2 to the power I minus 7899 into 1 by 2 to the power I, right? This makes sense. This is a loss of yours, the total game of yours. Here you are losing, here you're losing, but after some time you will not lose, right? Then this makes a better sense, right, guys? Does this make a better sense? Better metric, guys? That's what I'm asking to you.
Yes,
now,
sir.
what do you mean by more? You understand? 50% is more, 60% is more. You have to come to a certain value, right? P value? There is no P value. Like, it's no P value. I mean, P value. Yeah. Okay, anyways. Does it make a better sense, right? Does it make a better metric? This is a loss. You are getting loss. After certain time, you will gain. But this is some probability, right? So does this make a better sense? All of you, are you sure with it? Swapnil?
Yes, sir. Yes, sir.
Nasir, Kushal, Mayur? Swapnil, are you understanding? Hemant, Bhushan, Priyank? Yeah, bolo.
If I calculate the probability of this loss, if that probability is more than the gain one, then I will not play the game. Why will I play the game?
Yeah, so that's what you're calculating the loss in each case. Okay, you're calculating gain in each case. Okay, gain can be negative in some cases.
So I'm not calculating the loss or gain. I'm just calculating where will I up till where will I get the loss, and that corresponding probability I'll calculate. And if that probability is loss probability is more than the gain one, then I will not play the game.
Okay, sure, that's so fine. But what if you get
Until
okay?
the simulation
So okay, let's understand. Yeah, sure. You're very conservative. It's fine. Let's understand this. So till 7899. So what is the probability of getting till 7899? 2 to the power 2 1, 2 to the power 1, 2 to the power 2. Then you get 2 to the power what? 2 to the power 1.
13.
13 आ रहा है?
Means at 13 तक you will get the profit.
Okay, so 2 to the power 12 कितना हो रहा है? Can you calculate this sum? Someone? Swapnil, where you are finding difficulty? Can you tell me? I told you to revise the 4 hour videos. Did you do that? Can you calculate this sum, guys? So Sneha is telling a good algorithm. Yeah. Did you get the sum?
Sum is 0.99.
0.999. Are you sure?
Yeah, 7.
Okay. Okay, it's coming out to 0.999. That's very large. So you're telling that you will not play this game. This makes a lot of sense. Okay. Okay. That makes a lot of sense. Okay, this is nice. So this is a new metric that you guys are telling me, that if you will calculate probability of where you will lose, then you will give a mark of it. If it's more than that, then it's a very good idea. It's a very good idea. I think so. Okay, then I have to change the game a bit. Okay, this makes sense. Okay, so now my question is the following. My question is the following now to you. So you guys are speaking that 0.99, so that makes sense. So in this case also it makes sense not to play the game logically. So therefore what I did is that I reduce the money. How much I can reduce the money? Tell me, so at what percent of the game you will play? What percentage of the yeah, that's I will do now. That's what I will do now. That the probability of positiveness, that what we will do now. See, if I tell you that I will give you rupees 1, okay, I will give you rupees 1 over here. Then it will not make sense. Okay, what will make sense? I will tell you where it will make sense. I will tell you. Let's say now I will change the game by this. We have to pay a fees of let's say a rupee of 10,000 to enter the game. And what you will get is the following. If you get success in the kth toss, you get 2 to the power k times 4,000. This amount you will get. Okay? That is for the first, if you get first success, you get 8,000. If you get the second success, you will get how much? 16,000. I mean, second trial may. If you get third trial may, you will get 32,000. I will go on. So now will you play the game or not? You have to give a fees of 10,000. You see? Will you play this game or not? Because you have a probability of losing 8,000. You understand that? You have a positive probability of losing 8,000. Did you understand this? See, understand this very carefully. If I just tell you that you have to get in using rupees 1, okay, and or maybe rupees, just boil it down by 4,000 each side. Okay, that turns out to be 2.5. You have to give a rupee of 2.5, okay, and you play the same game. So understand this scenario. If you have to pay the rupees of 2.5 and you have to play the same game, let's say 2, okay, and for 2 you will get 2.5. Like you will lose 2.5 for 4. You will lose. Okay, let me give you the game properly now. So there are two aspects of the game. Okay, the two aspects of the game. One games gives you the following. Now this is the game. This is the idea where I'm showing you what it really means in terms of economics. Why I'm sharing with you, I will show you the in mathematical format. The real analysis will come up soon. In one game is that the entry fee is rupees 10,000. Okay, and how does the game work? The game works like this. For first toss, you get 2 into 4,000. Okay. For second toss, you get 2 square into 4,000, and it will go ahead like this. That means here you lose minus 2,000, and here you start gaining plus 6,000, plus 6,000, yeah, right, and it goes on. And next game, what I will do, I just boil it down, divide by 4,000. That is, you have to entry with rupees this, and first toss mein you have 1,000. In 2. That means you lose minus 0.5. Second toss mein you see 2 to the power 2. You lose. You gain this stuff 6. So now tell me which game will you play and why? Both the game are the same game. Do you see the idea? Both the game are the same game. Do you see the idea? Do you understand the game, guys?
Once again, will you tell?
Sure. So 10,000, one game you have to entry fees is 10,000, okay? And the probability of winning is, and if you win in the first toss, you get 2 to the power 1 into 4,000. If you win the second toss, you get 2 to the power 2 into 4,000. Okay, and it goes on. Second wala, I mean, what I did, I reduced it everything by 4,000. I divided by everything by 4,000. That is, your entry fees is rupees this. And if you play the game, you earn less. That is 2 to the power 1, that you lose therefore minus 0.25. That is 50 paisa. And you do this. Here you lose minus 2,000. You lose minus 0.25. So which game will you play? This is my statement to you. How will you decide it? This is my question. Do you understand the question? Both the game are equivalent game. You see, Nasir and all of you. I just review the 4,000 aspect. I divide by 4,000. Both the game are the same game. Understand this. This is the main part. Both the game are the same game. Both the game are the same game. So this is my question to you. Which game will you play? I will now go to each one of you. Bhushan, which game will you play?
I will play the first one.
No. Yeah, either you will play both the games or you will not play both the games. That's the idea.
Okay. Both the games or not both the games?
Both the games are equivalent, Bhushan.
Yeah.
Both the games are same actually.
But yeah, even if I lose at the first toss, I'm still gaining 8,000.
You're still gaining 8,000. What?
if we take in terms of entry fee, okay, the entry fee is right.
The entry fees is 10,000, right? And in the first toss you lose minus 2,000. Here you first toss you root 50 paisa, but both the games are same. But then you are gaining. So how will you decide in these two games? Tell me. It's a very real life game. Like you are asked to play both the games or reject both the games. Which one will you play? You have to decide in 1 second. Tell me, Bhushan, why and which one will you give? Will you play the game or not? Tell me, quickly. In a casino, you will not have so much time, Bhushan. Tell me quickly, yes or no? Will you play the game or not? I will just collect yes or no's, that's it.
I will play them.
You will play both the games? Okay. Okay, you can mute yourself. Hemant, will you play both the games or not?
Yes.
You will play both the games? Are you sure?
Yes. Yes.
Okay. Kushal, will you play both the games or not?
Yes, I will play.
Okay. Madhav? Okay.
Sir, I will play, sir.
Okay, let's do something. Let's add 2 more zeros over here. No, now this will become a bit. So now you will lose around 44 lakhs. Here 10 lakhs. So here you lose a minus 6 lakhs. You'll play the game, guys? I'm just doing the same game, man. Nothing more. I'm just cheating with you. I'm just saying this plain game. Tell me, guys, which one will you play? How will you decide? Now you told that you will decide how much you're losing something, right? How much will you decide?
So it will be minus 2 lakhs, I guess.
Minus 2. I did I do some mistakes? Oh, minus 2 lakhs. Yeah, you're right. So which one will you play? Quickly tell me. Bhushan, your answer remains same or not? Kushal, Madhav, Hemant. Mayur, Nasir, Polome, Priyank, Tanvi, bolo.
I will play the game, sir.
All of you will play the game or not? Both the games you have to play.
Yes, sir. Yes, sir.
Tanvi, Polome.
Sir, I don't understand you. If you don't play the game, so we have the option to just go with our entry fee. There is a
No.
seats with our entry fee.
There is nothing. Either you yeah. No, there is no first game or second game. You have to play either both the games or you go away from both the games. If you don't play, if you don't play, you will not get any money. The idea is you have to give some entry fees. Okay? And that's it. If you give some entry fees and then you can play the game or not play the game. That's the idea. People will play the second game, but we will not play the first game. Why? That's my question to you. Bolo? You're a bit quiet. Why? It's a very real life question.
Like seeing the second game, sir, it doesn't matter if you lose something. Like the amount of money you are losing is very less.
Yes.
So
And
you can bet on the second game, but seeing this first game, you see you are losing money just on the first toss, and after first toss you are gaining something.
so how do you mathematically model it? How do you give a metric so that you decide based on that? What is the metric? What is the metric? You understand the idea, basic ideas.
I will not play the game.
Okay, why?
Because losing in the getting the head in the first trial, it is 0.5, and getting the head in the second, it is 0.25. So getting a loss will be more. So I will not play the game.
See, I know the mindset of yours. So what I will do is that I will make it easy for you. I will give. So you tell 50% is the main cause of your concern, right? First, you are losing 50% opportunity. So what I will do is that I will give 10% opportunity. I will divide the rest of it with the other stuff. Will you play the game now? You understand the change?
Please explain again.
Sure. What I will do is that first toss में there was 50% chance. It was 1/2, 1, 2, 1/2, 1/3, right? This goes on. What I do is that I subtract. So I change half to 10%, 1/10.
Means when the loss or the failure probability was half, at that time all the sum of all success was also half. Now means 50-50 chance was there.
Yeah, that's what I was telling you. So, but people were not listening. People love their money. So, what she's telling that if you lose minus 2 lakhs, you're getting more than 6 lakhs. 6 lakhs is there. Here you're getting at least 6 lakhs of winning 50-50 chance. So, will you play or not? Sneha, abhi bolo.
Now I'll play the game.
So you want your friends to be there while you're gambling, Sneha? So that they can give you expert advices?
Of course.
Okay.
I sit with a panel of statisticians. So
Okay.
not to incur any loss.
No. That's how it not works, okay? If you go to statistics study abroad and then you will go to Los Angeles and you play the game blackjack, that's not how statistics work. You have to be very sharp at that point of time. It's just a matter of seconds. Okay? So, what is the idea? What is the difference that is causing you guys? What is the central? This is not a problem of statistics, it's a problem of economics. Can you tell me what is really going on? Can you tell me? Can you tell me what is really going on here?
The concept of opportunity cost.
Huh?
Opportunity cost सर इसमें से पहला वाला गेम में ही opportunity cost है तो उसके बाद में कोई opportunity cost है नहीं.
Okay, you're close. The idea is that it's about marginal utility, okay? What is marginal utility? The thing is that, understand this very carefully, guys. You guys are student. I am also a student, okay? To us, 2 lakhs is really huge. But this may be not huge, okay? Let's understand. Let's say if you just replace this by 250 rupees, just 10 times if you do, you get 50 rupees. For a beggar, this is too much, right? For a beggar, you will play this game, but a beggar will not play this game, right? You understand? You will not play this game, but Mukesh Ambani will play this game. Right, guys? You understand the concern?
Yes, sir. Yes, sir. Right.
It's all about the marginal utility. Okay, what is the marginal utility? So how do you calculate the value of the game? That's the idea. How do you calculate the value of the expectation? Can you tell me? Anyone tell me? Any ideas? This is the idea. So the random variable is not the money. The random variable is something else in the mind which is going on. You understand?
Yes, sir. Yes, sir.
So what is the random variable that is going on psychologically? Can you tell me? It's a very interesting question. Okay, all of you understood the idea that the second game, the chance of winning, Sneha is there in the chance of winning only. Chance of winning is not the idea, Sneha. Because in this case, you will play the game, but a beggar will not play the game. So it's not about the chance of winning, Sneha. You understand? The chance of winning is not that I can reduce down the whole thing. Money is the only idea. So how do you calculate this? So I give you two random variables now. I gave two real life examples to you and shown you that your metric is totally different. And chance of winning is not at all on difference, okay? I can make this for you. Okay, play this game at your home. I will make this. I will make a game for you where you will lose 0.01%, 1% of losing, okay? The same game. I will make 1%. Okay? I will just make this game, just calculate the odds. 1% where I will tell you that you will lose minus 2 lakhs. Okay? The rest of the thing will be positive. All the things. Sajada Sam is 1. In this case also, Sneha, you will not play. I am 100% sure. Will you play? Sneha? If I give you that you will lose minus 1% of losing that money, 2 lakhs, will you play the game or not, Sneha?
Yes, I will play the game.
You play the game?
Yes,
I am not sure at all.
No, of course I will play the game.
No. Then also you will think, if I make it 2 crore, then tell me.
Then I have to think.
Then you will think, exactly. The beggar will also think. Okay. So the idea is that it's not in the random variable. It's not in the money, okay? It's not in the probability, okay? Which you're thinking wrong. That's why I wanted to think you in the beginning. Okay? You think that the money, the problem was in the money. The problem was in the probability. The problem is not in the probability, okay? The problem is in the value of money. Do you understand this idea, Sneha?
Yes, I've understood now.
Yeah, the problem is the value of money each one of us perceive. Okay? So all of you understand this idea, this simple. And now I will tell you what is the real random variable. Did you understand this idea? You must understand. That's why I just showed you this. Priyansh, Polami, Bhushan, Nasir, Sneha, Mayur, Madhav, Kushal, Hemant, Bhushan. Yeah, did you understand? All of you good?
Yes, sir.
Yes, this is perfect. So this is the basic idea that you will really think about it. This is the value of money. So how do you calculate the value of money? See, the idea is that here it's something else we are thinking about. It's not, the loss is not 2000, okay? The loss is something else. The gain is not 6000. The gain is something else. So there is something called marginal utility of money. I will just search it and share the result for you.
Good grammar.
Just give me a minute. I will just search it and share the result for you. Oops. कहाँ गया भाई? I was having that graph. कहाँ गया? Anyways, the basic idea was this. Is that the value, the loss is actually not rupees X. So there is something that, you know, as a person become more richer and richer, the value of money decreases. Okay? Let's say Sneha becomes a billionaire. I don't know how many billionaire zeros are there in a billionaire. Anyways, whatever it is. So to her, the value of money will become less. To her, 100 rupees is question, like it's 100. Like to her, enrolling in this course of Cheenta is like, it's like her general pizza ka price, okay? It's like that will be to Sneha and all of you, in fact, because we are students. The idea is that the value of money decreases with time. The value of money decreases with time. This is the idea. With the more money, okay? So in fact, you can do it in root x format. You can model it by log x format. Okay? You can model it in this way. Now think about the game. Now think about the initial game. How much money will you expected to lose, expected to gain? Here the expectation is the actual value, okay? You're thinking expectation is not the actual value because you're thinking that you're losing out money, okay? Mukesh Ambani will think the expectation, okay? Not how we are thinking. Okay, so this is the idea. So 1 by 2 is clearly 2 to the power 1. But here the value of 2 to the power 1 is not 2 to the power, it's actually log of 2 to the power 1. Okay, the value of 1 is log. So similarly, it's instead of it's not summation 2 to the power I by 2 to the power I. It's actually summation of log of 2 to the power I by 2 to the power I. Do you understand the idea? Now calculate this value. Calculate this value now. Calculate this series. Summation of log of 2 to the power I by 2 to the power I. Calculate the series. Now, just every one of you, calculate the series now. Calculate the series and just tell me what is the series. It's very simple to calculate. Log 2 will come as a common. Summation of I by 2 to the power I. You know this, it's AGP series, right? S is equal to 1 by 2 to the power 1 plus 2 by 2 to the power 2 plus dot dot dot. You do S by 2. You get 1 by 2 square plus 2 by 2 cube. It goes on. So you take the difference of it. You get S by 2 again. And you get 1 by 2. So 1 by 1 plus 1 by 2. And therefore you get what? You get this. Therefore you get S is equal to 1 plus half plus this, which is equal to 2. So the marginal utility value is 2 into log 2. That is what? What is the value? Now you will decide upon this whether you will play the game or not. Do you understand the idea, guys? This is really exciting, right, guys? Do you like the idea? You like the idea how it really works in real life? It doesn't work like probability and what you will do. How to model this scenario? This is a beautiful idea, guys. Okay, this is the reason with this is a combination of statistics and probability together. So what I'm doing, probability and economics together. Kushal, you being economics students, did you understand this?
Yes, sir.
Do you like this?
Yes, sir. Yes, sir.
Good. So this is the idea of marginal utility, guys, and don't think about marginal utility. It's about creating the right random variable for you. Okay, creating the right random variable for you.
Sir, I have a question, sir.
Sure.
Sir, in economics, I have studied that with the concept of marginal utility, that after consuming more and more of the good, the marginal utility starts decreasing.
Exactly.
So after playing many and many games, here also the same theory remains, because when I'm playing more and more game, I'm getting the higher amount.
Yeah, exactly. No, the significance doesn't remain same. The significance at all doesn't remain same. The value of the money decreases. Like it's like this. It's like this. It's like this that I mean, it depends upon how much you invest. Okay. The idea is that it depends upon how much money means to you. So the amount of money is not 1,000 over here. It's log of 1,000 over here. The value of the money. I think you can actually denote this is what respect you have. Okay. Like what I'm trying to make sense is that this is the only way you can actually distinguish whether you play this game or not. That's the idea. Like for example, what you're trying to say is that for a person, the value is different. That's the idea. For a single person, the value is different. So how to model it using a general scenario? Like, let's say, The log of this curve is actually what my idea is that if you enter with rupees 230 this, the value of this will become less and less. If you enter this, the value of will become more and more in some sense. It depends upon this value what log curve you will take. Okay, there are various log curves you can take. Okay, the thing is that it's just one example. The log will differ in different cases. The value of the money will differ. The value of the money is not. The idea is that this 10,000, whatever you are joining with, okay, and if you get rupees X, okay, to you the value of money is not X, not 10,000, but something more. Okay, that's why you're not playing. You're losing out more. Okay. So you decide your value of the money at the beginning only. For example, as I told to Sneha that if I with one person, if I ask her to play to bet about this minus 2 lakhs, she told that she will do it. But as I told to minus 2 crores, she will not do it. So the value of the money, you will see the expectation will come out to be infinity if you just do it. But the value of the money will be different in that case. How to model that value of the money? You model it by log x usually. There are other mathematical ways of doing it. Okay, that's the idea. Did you understand?
The sum of that log 1 is what it is given.
Sum of the log 1?
Yeah, this one means log to the power I by 2 to the power I. The sum is means indicating what? Means
it's a utility value. Okay, it's a utility value of the game. Like how much valuable the game is to you.
means it's giving a value of 2, 1 like this means.
It gives a value of 2 log 2. Initially, you have a value 2 log 2, okay, and initially you're joining with rupees what? You're joining with rupees 10,000. So difference the sum log of this minus log of that, which is more to you.
Then sir, it's a utility function for a person.
It's a utility function for the sum. You're right. How much valuable the whole thing is.
Yeah, but how we can say that the utility function for money will be the same for each and every person? Like in terms of log, you are defining it.
Yeah, that's the idea. So the log is not. So a log is just one case. You can take other functions also. Okay. For different people, it's a different function. I'm just giving one example. For different people, it's a different function. You see it. That's the idea. And depending on that, you take the decision. Did you understand the idea, guys? Any doubts?
Yes, sir, got it.
Others? Polomi? Priyansh?
Means I'm not understanding that ln2 value what is I'm getting means what is that means that is the amount I'm having or that.
No, that is the utility. So as I told, okay, the idea is that utility is that 10,000 is not 10,000 actually. 10,000 is log of 10,000 value. Like you understand that value is different. 2 to the power I, this rupees is not 2 to the power I. It's log of 2 to the power I in some sense. I mean, you calculate in a general framework. Okay, for other person, it's 100 into log of 2 to the power I. It's a like, it depends upon what the value of the money is. Like, he calculates the value of the money you have, okay? It's not the money you have, it's the value of the money. It calculates the value of the money. For one person, it's log x. For another person, it's log 100 log x. Okay, I'm just giving an example. For other person, it can be something else. It's a value which is giving. And the value differs from one person to another. That's the basic idea.
So it depends upon the capital being invested. That's the utility.
It depends upon the
capital, like 10 lakhs or 2 lakhs.
Yeah, exactly. It depends upon the initial capital you're losing or like whatever you're gaining.
Okay.
So you calculate the entire gaining, calculate the entire utility, and then you subtract it from the same utility function of that value, whether it's more or less.
So since here for that log 2i, since it turns out to be positive, so that so it means we go with the game.
We go with the game. It's dependent upon that value. Whatever that log is, yeah, you will go with the game. Yeah.
Yes, sir. Since here we got 2, that is, since it's positive, here we go with the game.
No, actually, okay, I think I need to continue this with the next day because my another lecture is coming at 8:30. Okay, I will just continue with next day, okay? Because my 8:30 is another lecture. I am getting calls and stuff. I will come to this with the next day, okay? In our next Monday class. Okay? Bye bye. Yeah,
So
you
our utility function is our random variable.
exactly. You're right, Tanvi. I hope it was Tanvi, right? Yeah. The utility function is a random variable, not something else. Okay. Bye bye, guys, and I will see you next day.